Hello, ladies and gentlemen. Today we are going to take a look at graphing linear inequalities. So making a picture of lines when they have greater than or less than, greater than or equal to, or less than or equal to involved. For this, you're going to need your notebook, obviously, to take some notes. I also made that little guided note page that you should glue into your notes. It's a helpful way to kind of organize our thoughts here today. And a calculator may be necessary and a ruler if you like to draw those straight lines. So our learning target today is that we can graph these linear inequalities and we can use shading and dashed or solid lines accurately when we need to. So let's jot down a few key points here to get us going. When you graph linear inequalities, ladies and gentlemen, the first thing you're going to need to do is actually make a graph of the line. Just like you would graph any other normal line, you could do this a couple ways. You could solve for the y to get it in y equals mx plus b form, or you could graph it using x and y intercepts, which is another method that we've talked about. After you graph the line, you need to make the determination whether it's going to be solid or dashed line. And that is given to you in the clues and the inequality symbol, okay? If it's just a greater than or less than versus a greater than or equal to, less than or equal to. And then we need to shade, because graphing a linear inequality is not showing just what line represents the solution, but what region on the graph represents a bunch of solution points that would work in that inequality. And then always, always, always remember to flip that inequality sign if you're dividing or multiplying by a negative number in your solving. So please be aware that since we are dealing with inequalities again, we need to be aware of that special rule. And always, always, always be on the lookout for those vertical and horizontal lines that we have to graph and shade. So here's the one example I want to make sure you have in your notes. We're going to do this so sort of an organization here. You see the example up above. You see the problem up above, and then we need to go ahead and graph him, and we're going to graph and shade him here. So if I go up here and I want to solve for the y up here, or I can decide to graph him using x and y intercepts. So I think what I'll do on this one is I'll solve for the y. I'm going to subtract the 2x from this side, subtract the 2x from this side, and I get negative 3y. Oops, sorry. Negative 3y is less than 12 and then minus 2x. Now if you like that minus 2x, you can write it first. And then we're going to go ahead and divide by negative 3, divide every piece by negative 3 to get the y alone. And I end up with, I'm going to write it over here to the side, y is greater than now, ladies and gentlemen, because I divided by a negative, I need to flip that inequality sign around. And then I do like writing my slope first, so I see negative 2 over negative 3 gives me a 2/3 slope. And then minus 4. So if I go and I want to make this graph, that's a 2 up there, it's kind of hard to see. I want to make this picture of this graph. I'm going to go ahead and plot some points here. Now remember the negative 4 represents my y-intercept. So I'm going to go down to negative 4 here and place a dot. And then I am also going to go from there and count my slope up to over 3. Okay, up to over 3. And now that I have those two dots plotted, I now need to make the determination whether I'm going to make a solid line or a dashed line through these two dots. Now you make a solid line, guys, when it's less than, equal to, greater than, or equal to. You will make a dashed line if they don't have those equal to options here, so like a less than or a greater than. So if I'm looking at this here, I'm seeing that my symbol was just a greater than because I flipped the sign around because I divided by a negative. So I'm going to go ahead and make a dashed line through these 2 points the best I can here without actually using a ruler on my tablet here. Here we go. There's my dashed line. And then I need to shade. Now determining which way you shade here is basically you could look at that symbol greater than or less than to get a good idea. I want the region of points that would give me solutions here that would work. You're looking at the inequality here, it says greater than, so most of you would say, oh, and then you just shade above. That would be a good method. You could shade all of this. All of these points represent the region of solutions then. And we would want to check to be sure that we shaded the right half, guys, because sometimes it's hard to tell those shading properties or which side you shade. So we would go ahead and check a point. The easy point that is shaded right now would be 0, 0 for us to check. So I'm going to plug it back into the original equation. 2x minus 3y is less than 12. And I'll go ahead and put a 0 in for both. So 2 times 0 minus 3 times 0 less than 12. 2 times 0 is 0. 3 times 0 is 0. So I'd have 0 on this side. Is 0 less than 12? Question mark. Like that's what we're checking. And the answer to that question is yes. So because that 0, 0 point worked, it should be shaded. And that is what we have. That means our shaded region is correct. It's either going to be above or below the line each time. So we need to decide which side needs to be shaded. And if you aren't sure, you can always check one of those points. Okay, this was our one example here today. It's probably coming back to you. You did quite a few of these in Algebra 1, and I want to thank you again for taking good notes.